We're going to be taking a look at function templates. This is going to allow us to create functions that can easily switch between data types to make everything nice and easy. Say we were to design our entire program using integers, and then we realize that actually we wanted to use doubles. We'd only need to go ahead and change the data type of the variables we're using, and then we don't have to actually go back into the function and change all these things. It will save us a lot of time. So we're going to design this entire thing in the main.cpp to keep things nice and simple. So before our main, I'm going to go and type the keyword template. Now I'm going to go and use triangle braces, and I'm going to write class, and then I'll pick a name of a class, and whatever I pick here is going to be the data type, for example, that we're going to use. So I'm going to use lemming here, and this means that in the places where I would normally write int or double for the data type I want to write, obviously this is not inside the main, I'm going to use lemming instead. So I will use the word lemming. So I write that template there. Now go ahead and create a function. Now obviously, if I'm going to be creating a function that can switch between data types, I'm going to need to return something, and I'm going to obviously not know what I'm going to be returning. So I can't go ahead and write integer or write double here, or obviously I can't write void because I want to return something. So I'm actually going to go and use this new data type right away. So I'm going to use the lemming data type. Now go ahead and create the name of the function. I'm just going to call this the addition function because I'm going to be adding two numbers together. Just keep it nice and simple. So I'm going to want to pass two parameters through this, which will allow me to do it. Now I'm not going to go ahead and pass integer parameters because I don't know if I'm actually going to be working with integers or not. I could be working with integers, doubles, floats. I don't know what I'm going to be working with. I'm going to be passing lemming x and lemming y. So these are going to be the two parameters that are going to pass through. And like I said, I want to return something, right? So I'm going to just be returning x plus y. Simple enough. So whenever I call upon this function, I expect the two parameters that I end up passing through it, so whatever numbers I end up putting here, I expect those to be added together, and then that will be what we print out when we decide to print out this function. So we have all this already up here. We have our function. It's a lemming function, and it's going to be using lemming parameters. Nice and simple. So we'll go down here in the main, and I'm going to go ahead and create some variables here just to give us some numbers to work with. So let's go ahead and create integer a, and I'll assign that a value of 5, and let's go ahead and integer b, and we'll keep it 10. So keep it nice and simple. So now we'll go ahead and we can go ahead and use this function. So I can go ahead and write the print out. So I'm going to print this function out, cout, and I'll just write the addition, and I can write a, b, end line. Okay, so this means we're going to pass a and b through. We already said that a is going to be an integer 5 and b is going to be an integer 10. I'll go ahead and pass this through, and we can expect this to add it up to 15. Is it going to be correct? Yep, we get 15 added up right over here, so everything is perfect. Let's go ahead and test this out even more. We can go ahead and use a double, which is going to allow us to use some decimal places. So we'll go ahead and write double for both. Now let's go with 5.5 and 10.342. All right, so those are two doubles right there. We can go ahead and add those together. We'll see what happens when we add them together. The bill succeeded, and we get this number right over here, 15.842, which is correct. If we add it up, we see that's correct. So this is cool. We didn't have to go on up here and change everything. Before we would have like integer addition, then we'd have integer x, integer y, and then we would return x plus y. Now if I wanted to make this switch over here, I would need to go up and write double addition, double x, double y, and then return xy. So you see where we're saving a bit of time by making this template. Now we're using lemming data, and lemming data can be whatever we want. Now the one rule is it needs to be consistent. I can't just go up here and add integers and doubles. We can confirm this right now. What if I were to go ahead and put integer a here, and obviously go ahead and make this an integer. So say we're adding integer a and double b. Are we able to go like that? And right away we obviously see we're not. We get the error right away, and everything goes crazy. You can even try to build and run it. It's going to build failed. Everything starts going crazy. So although this is flexible and this gives us the ability to not have to go back and change everything if we were to want to change our data type from, let's say, integer to double or double to integer, you cannot add things that are different. You cannot add integers and doubles. That's crossing the line. You have to make sure that everything that's going to be added here, or everything that's going to be going into the lemming, the data you're using for lemming has to be the same, right? So if you're using lemming, it all has to be double or it all has to be integer. You can't go and add them together or whatever mathematical expression you plan to do with them. Everything inside the lemming needs to be the same data type. So hope you guys understood that. If you have any questions regarding function templates, please leave them in the comments below and I'll answer them as soon as possible. Hope you guys enjoyed this video, and I hope you're enjoying the rest of the series. I'll have more videos coming up after this.